Potential energy is the energy stored in a system and associated to a conservative force. When the force is conservative, we can obtain the value of the work done just by solving the integral of the scalar product of the force and displacement for the initial and final positions. This tells us how the potential energy stored in the system has changed between both positions. For example, when our friend raises the rock, it is doing work on it. And since gravity is a conservative force, this work depends only on the rock's initial and final position. This work is equal to the change in the so-called potential gravitational energy of the rock. The sum of the kinetic and potential energy of a system is called mechanical energy. We know the work done on a system is equal and opposite to the change in potential energy, and it is also equal to the change in kinetic energy. Then, it follows that the change in potential energy and the change in kinetic energy must be equal and opposite. In other words, the potential energy lost by the system is transformed into kinetic energy, and vice versa. This means that the initial mechanical energy of the system is equal to the final mechanical energy. The total mechanical energy of the system is conserved. Remember that this is only true for conservative forces. If there are dissipative forces, such as friction, then part of the initial energy is lost as work done by those forces. Conservation of energy is a very useful concept to solve problems that are otherwise quite complex. For example, how would you obtain the speed of the cars in different spots of this roller coaster?